Alright, so this problem here is problem 9, chapter 9, problem 121, and then I'm just doing part C, which is for water vapor. It's asking us to find the critical pressure in bars as well as the temperature. For something like this, it really helps to draw out just even a rough sketch of what you're trying to solve for. So, I'm definitely not an art major or anything like that. Critical pressure is going to be over here, whereas this is the rest, and it should be theoretically at a constant pressure. Okay, typically when the pressure is going to be exiting like this, it's going to go down. So I assumed an average pressure, or excuse me, I assumed an average temperature. For this problem, I just used 450 degrees, or 450 Kelvin. It's an easy number to use. We have most of the information in the tables. And then if I do the specific heat over our bar like this, we need to come up with some sort of a value so that we can solve out for the K value. Being that I have 450 degrees or 450 Kelvin, plug it into the long equation that I worked out. Sorry, I'm gonna skip a few steps here. When you plug it in for the T's, it'll be right here, and then there's a couple other places. This is I'm gonna just pause it temporarily while I jump ahead and type it all in, or write it all. Alright, sorry to make it all jump around, but that was a lot longer than I remembered. So, when you plug in the temperature for those values, you're gonna get your ratio here, and it should equal out to 4.175. Then when solving for the K, we can do the ratio of specific heats. And that, again, we can simplify a little bit more. The CV is the same as R bar minus 1. So when we do that, we plug in this ratio here to this value as well as this value, which will give us a single solution at the end of 1.3149. So then solving for the critical temperature, we have our T naught over critical temperature. That equals to 1 over 1 K minus 2 times 1 squared. That's going to solve down a lot. Plus 1 over 2. Now we have our initial temperature of 500 Kelvin over what we're solving for, the T star. And then we solve for the K right there. Excuse me, I'm going to erase some of this to get it cleared up. Of 1.3149 plus 1 all over 2. Plug that into your calculator and you're going to come up with 431.98 kelvins for your critical temperature when you multiply or solve out the 500 also. Next we need to solve for the pressure. We use a very similar method. Oops, almost forgot a variable. There we go. So again, we're just going to plug in the values we have. We were given the initial pressure as 8 bar over the critical equals 1.3149 plus 1 over 2 over, or in the 1.3149. Just for the sake of space, I'm just going to subtract out the 1 automatically. When you plug that into your calculator for you'll get your critical pressure to equal out to 4.344 bar. So that's pretty much it for doing just the water vapor. And again, a lot of these values are out of the tables. We'll make it a little prettier here. We're going to have part C, your temperature critical and pressure critical, 4.34 bar, and critical temperature is going to be 432 Kelvin. Thank you for watching part C of problem 9.121.